Hello, everybody. Welcome to the CoinGeek Weekly live stream. I'm your host, Mr. Kurt Wuckert Jr., rocking live from South Florida, where it has suddenly gotten seasonably warm, as you might be able to tell from my slightly shinier face than usual. I actually just got back from my walk after coverage of the Satoshi trial for the whole morning, and said, well, I need a little bit of sanity in my life. So I went for a walk, and now I'm a little too warm sitting in my chair. So if you start seeing sweat make its way through my IBM blue Oxford dress shirt, I apologize in advance. I'm only human. So if you're watching live, please like, subscribe, hit the alert bell, all of that jazz. It really helps. I want the camera to stop moving. It's driving me nuts. Stop being digital camera crazy. So yes, please like, subscribe, hit the alert bell. Let your friends know we're live. We're live with actually one of my favorite people in Bitcoin, and a person who has not ever made an appearance on the live stream, although he did make a special appearance at London Blockchain Conference last year. But he is one of the guys in the driver's seat of the Teranode project over at Bitcoin Association, or BSVA, or whatever they're calling it now. I suspect it will be different in 6 months than it was now, or 6 months ago, but you know, the lawyers make those kind of decisions as a rule. So we'll have Siggi on in a few minutes. I want to take your questions. So if you have difficult questions about Teranode, about scaling in general, we could even talk about you know, just some of the politics around Teranode even, please bring them, put them in the troll box. If you can get them past Mr. Ward, I will be very happy to ask them of Mr. Oskarsson. So Siggi is a kind of an OG, although he is a guy who generally keeps a private profile. So I'm excited for him to have his debut here on the show, and his debut to you, the fans, the people that make this show possible. So if you're watching this in rerun, you can also like, subscribe, and hit the alert bell, because, well, the YouTubes and the all the interwebs, they like to jerk us around a little bit. Unless we know the algorithmic gods, we beg them for their good graces, and by doing those things, by interacting with our stuff, comments and things under our videos, it lets our cyborg overlords know that you enjoy the content and that you'd like to consume more of it. So please do all that, get that out of the way. I've had a long morning for two reasons. So daylight savings happened over the weekend in the United States, but not the EU or UK. So I'm 1 hour less rested than typical. And then I woke up, as I do, at 4:30 in the morning to get my my morning stuff done, drink my coffee, you know, mosey around a little bit, say my prayers, lift a little weights, splash my face and freshen up, and then hop on the air to pay attention to the Satoshi trial stuff. And then I come to find out, wouldn't you know it, daylight savings times doesn't happen till next week in the UK. So I was up an hour earlier than I needed to be. A little bit disappointing for me, but I got in a couple more sets on my bench, which I've been working out on. So anyways, that all worked. If you want to catch up on my stuff, please check my thread. I've been basically acting as an amateur stenographer, not steganographer, but stenographer for the case. You can follow my threads. Subscriptions appreciated. If you follow me as a premium subscriber, you will get my video content as it gets made. I give a 5-minute video summary at the end of every section. So that's about 4 minutes into the episode, which means it's time for an ad. And we'll be back with Siggi Oskarsson at the end of the ad. Mr. Ward, please play it. I need a break.
BSV is more than another chaotic commodity craze. BSV blockchain can do more than just be a crypto investment. It can help you get more out of your games, share more of your art. BSV makes more things possible.
What's up, Siggi?
Hey, Kurt, how are you doing?
I'm quite well, man. How are you?
I'm good. Busy, very busy.
Yeah, I'm sure you are.
Thank you for the lovely introduction, by the way.
For sure. No, you're one of the people that more people should know about. I think a lot of attention goes to people who are good at getting attention, but maybe not good at anything else. And you are quite the opposite in that you have a tendency to keep your head down and make cool stuff. So I appreciate you. Actually, to that, could you give us a little bit of background? Like, you're not a new guy to Bitcoin or big block Bitcoin or any of that. Could you maybe go over your CV a little bit on some of the stuff you've been involved in the past?
Yeah, definitely. So I'm going to go back all the way back to when I first got introduced to Bitcoin. I think it was in 2013. I think a lot of people got, so I'm not very early, but this is when a lot of people got introduced to Bitcoin when the price was going up and getting involved. And I was on the Bitcoin Talk forum and on Reddit and all these places where people hang out. But just like now, I'm private, so I was more of a lurker than I wasn't really writing anything.
Yeah.
I did try my hand at a couple of silly little apps and things like that, but it didn't really go anywhere. But I was following all these discussions. I think in 2015, 16, I don't remember the exact date. It's a long time ago. But then we had the big block discussions, and the arguments came out to limit the block size. And I just remembered at the time that this is not what Satoshi was about. He talked about big blocks, and we know, you are the historian, right? So you know all this stuff. And I just got totally turned off from Bitcoin, started looking at other things, got into Ethereum, got into IOTA, all kinds of other things, because I thought this is just, these guys don't know what they're talking about. Mm-hmm. Until I heard, I think it was the Arnhem speech that Craig gave. Sure. And it was like, wait a minute, this guy is saying all the right stuff. Mm-hmm. And then started getting back into it. And then when the split happened in 2018, I think it was the first one, to BC8, and then 2019, especially with BSV, then I was really started getting into development and wanted to do some real development on this stuff. Because I was stuck in a corporate career before that, working at a big company, making money. I did stop that, but freelancing for a little bit, but I always wanted to work on some Bitcoin stuff. Mm-hmm. So I did work, I'm going to get the order wrong, but I don't think that's the most important thing. But I worked on with the guys from Tonic Pow. Mm-hmm. A little bit, worked with them on in the background, and I did Anna with George Yossi Samuels. Did that just together. Of course, Jungle Bus, first version of Jungle Bus.
Absolutely.
The Bucks wallet, and later Arc, and now Teranode. So I've been doing a lot of stuff in the background for the last, I think, 4 years now.
Yeah. Involved pretty closely in like protocol development, not just app development, but also some of the stuff related to Bitcoin schema and some of those things, which is sort of a Tonic Pow adjacent concept. But yes, as I understand it, you were involved in sort of architecture and implementation of those sorts of things as well.
Well, there was, I think Luke is the lead from that. Well, Luke from Tonic Power. He's the
mad scientist for sure.
He's the mad scientist, yeah. So I was working with him, but I did some stuff on identity, like the back protocol that I think is in some of these open social protocols, and I did create a blog post network that never went anywhere because I'm not a community builder, and that's kind of important when you're trying to build a social media site. So I was involved in that to some extent, yes. Yeah, but I always think when you talk about protocol, I always think about the Bitcoin protocol itself, but it's not that deep. I mean, these are like protocols, what would you call them, layer 2 protocols or something on top, a lot of the up return stuff. So exciting times when Unwriter came with all this stuff at the time. For sure. A massive explosion of creativity. So it was around that time. Yeah, that was fun.
Cool. So transitioning, I mean, you're one of the funnest guys I've gotten to work with. You did help with the Jungle Bus implementation. Frankly, I think you probably did most of the heavy lifting on coding it in at least the first iteration. So, but working with you and Luke, like Luke is an architect, and me and Luke kind of trying to decide like what do we actually want the product to do, and then handing it over to you to give both your expert feedback and then literally do the labor of putting it together. Such a good working environment. So it was a little bit bittersweet for me when you wanted to make the transition, and it was such a big opportunity that by all means, just for full clarity for everybody watching, I was 100% supportive of Siggi going and working on this project. But there was a part of me that was like, but we were such a fun team. So, but making that transition and over to BSVA, which I think it's been about a year now, maybe a little bit more.
Yeah, about a year. Yeah.
And so
I was working with Tal before that. So it's about a year and a half in the family. Yeah.
Yeah, for sure. So a little bit of the stuff about let's talk about the transition from like mAPI to ARC, and if there's any sort of analog there that can be analogous of moving from BSV node or SV node over to Teranode. Like what are the steps to do that? How is this architected? Can we kind of go over, because I think a lot of people are still really confused about what ARC even is or what mAPI was and all of that. So let's start there and then maybe talk about more broadly these sort of modular systems and overlay networks and sort of rethinking the network as a whole.
So I was tasked with creating mAPI 2.0. And so starting doing that in the first week, and then I had together with Simon Ordis, that was the other developer on the ARC project. We spent a couple of days in London, and we were really thinking about, what are we actually doing? What are we trying to do here? And we wanted to challenge a little bit. I'm not just creating a mAPI 2.0, but thinking about what is more Bitcoiny, because mAPI is not really Bitcoiny, because there's a lot of asynchronicity in Bitcoin, and we have the peer-to-peer network and all that kind of stuff. So we thought, can we create something that actually works on the peer-to-peer network and can actually outlive mAPI to be a part of the network instead of just relying on a node? So it wouldn't have to necessarily rely on a node, but something that also scales massively. So those were the two things that we wanted to do. We just tried to think out of the box. How can we do that? And we came up with all kinds of things. We came up with the Metamorph service. This is almost like a slingshot into the peer-to-peer network, or the peer-to-peer network integrated in there. And it turned out that we're a little bit early, because especially the BSV nodes, they are locked down. So you cannot just, as a participant, join the peer-to-peer network and start throwing transactions out there. So we had to link that to a miner. That's the reason why it's now running at Tal and Gorilla Pool, I believe. Yep. It's not because it's not designed. It's designed to run somewhere else. So, for instance, Handcash should be running their own ARC instance, and it should just be joining the network and doing things on the P2P. But it's just not possible at the moment with the current SV node. So those are some of the things that we tried to do with ARC. And one of the most, I think, important things that we realized, and we came up with a new transaction format. And that's probably going to freak people out when they hear that for the first time. But it's not really, we're not changing anything. It's set in stone, so we're not changing anything. Yeah. But we realized that when somebody's creating a transaction and you're signing that transactions and you're sending it out, you remove some of the data that you actually need to create the signature, and you do not send it to the Bitcoin node. And that's basically the previous script and the previous Satoshis. And so when you do that, the node needs to look that up in its database. So this is horrible for scaling things out, because you have something, you throw it away, and then the node needs to look it up. So we came up with the extended format, which basically just sends that data with the transaction. And that has now been translated into the new Teranode as well. So transactions that are sent to Teranode need to be in the extended format. So the ARC project was in that sense was very interesting as a step up to what we did in Teranode. Learn a lot of things about the peer-to-peer network, about the node, about Bitcoin in general, and used some of that to take into the Teranode developments.
So that brings up an interesting question, because I think one of the major innovations actually in the Genesis upgrade from 2020 was the elimination of a standard transaction format. Like BTC, BCH, and basically every other blockchain has a standard transaction format that must be followed. Are you saying that Teranode cannot work without the extended format that's been derived here, or what's the how tightly are we married to that?
We're actually fairly tightly married to that, but
okay.
And this goes back into this goes forward into the discussion we're going to have in a little bit about the overlay nodes. Yep. Is that Teranode's an absolute beast, right? We're supposed to do the impossible, and I'm quoting Mr. Craig Wright here. This is the impossible project, to do 1 million transactions a second. And so you need to start thinking differently, and having all these lookups and things in your database at 1 million a second, that becomes a nightmare. So if you can prevent that, let's do that. We do that with the extended format. But if you think about a very large network that is doing 1 million transactions a second, there's a lot of overlay nodes that could be an ARC instance, or thousands of ARC instances that are doing a small part of the whole work. and they could do that lookup. So why do we have to do that lookup? So it's basically about sharding out the work that needs to be done, not have everything being done by the node. And I remember that one of the quotes that one of the things that Craig repeats, and I'm probably going to get the quote wrong, but he repeats this many times: why should I as a miner be doing other people's work for free?
Sure.
So I mean, I'm as a miner, I just want to mine transactions into blocks. So I'm going to do the bare minimum that I need to do that. So that's how Teranode is designed, because otherwise we cannot scale. If we do have lots of other services, we have a RPC endpoint for the mAPI, and we have ZMQ for listening. We have all these extra things. It's going to make it a lot harder to scale. Why should we do that? Somebody needs to pay for that. So it's a service somebody can offer later. So those are some of the design thinkings that we brought into Teranode. And this extended format, we haven't gotten too much pushback on it yet, so it'll be interesting to see if we do get that. But the idea is that information is available somewhere else. Why do you throw it away and then have us look it up again? That's the whole thing.
Now that I think about it, I'm trying to, I have no data. I've never actually looked into it. Is how much are people deviating from the standard transaction format, even though that they can now? Like, people are still probably
when you talk about
the
standard transaction format, you're talking about the actual script in the transaction, right?
Essentially, I mean, that's one of the major things is that, like in Bitcoin Cash, we inherited the standard Bitcoin Cash transaction format, which I don't actually know the details of. I know that it's about the order of each script that runs in a transaction. And so you can't run those scripts in different orders, as I understand it. Now, that was loosened and allowing scripts to run in a different order than standard, meaning that once it's unlocked, you can have the stack do any number of things. It might even just be limitations on how many scripts can run per transaction or something like that. But I'm actually a little unclear on how firm that standard transaction format is in BCH. So I'm not sure on the details.
I think the the assumptions that we were working under. So if we're wrong, we're going to have to fix quite a lot of stuff.
Sure.
But the UTXOs, the transaction outputs that uses inputs for the next transaction, they should be able to run in parallel. They have no relation to each other. So they cannot have a relation to each other. So they run in parallel. That's one of the things that we do. We run a lot of things in parallel. And I think when you're talking about the standard transaction format, I think you're talking about like pay to script hash, which we've gotten rid of, pay to public key hash and stuff like that. We don't really care about any of that. So in a Teranode sense, Teranode will process whatever you give it. If you give it a valid transaction in the sense of the script is valid, the signatures are valid, and the signatures are actually part of the script. You don't have to create transaction with scripts. You can do that without scripts. So whatever the input and the output is valid, that's valid. We don't really care. Yeah. So and one of the things that people have also asked, maybe I'll just address that immediately. When you're scaling something up like Teranode, and we are testing now with very small transactions, and that is because we're exercising a lot of the system. The system that actually does that script validation is extremely shardable. That's actually the easiest part of the system. We thought that was the hardest. That's the first thing that we did. It was the transaction validation. We optimized the hell out of it. We introduced some C++ code to do that very fast because the whole Teranode is written in Go. But that's actually the easiest part, scale. So
I would have guessed that'd be the hard part too. Because it is the bottleneck in SV node. It's always validation, and everybody's mempools are out of sync because of people struggling to validate what's coming across the network. So that's interesting. I think that's probably a point where I can mention that what we are doing in Teranode is we're kind of like flipping the model on its head. Because what happens in the SV node is there's a lot of validation happening in the mempool, but also when the block gets mined, there's a validation step that happens again. So there's a lot of processing. Like every transaction is processed multiple times, and we don't do that. When the transaction enters the Teranode, we process it immediately, and after that, we mark it as blessed. This is how we call it internally. And after the transaction is blessed, we don't really care about how big it was, what the script was, anything like that. We just have the transaction ID, and that's all we need to do block assembly and propagation and all that kind of stuff. So we only validate it once, and that is very shardable. And after that,
the system becomes a lot simpler.
Sure.
There are some caveats to that. It's very detailed. We're not going to get into, but it does change the way that you think about a Bitcoin node. That we think about Bitcoin is very different than the BSV node now.
So let's get into that. If we were to give like a Eli 5 version of what Teranode is relative to SV node, is there a good way to break it down really simply, or I guess I'll just let you peck away at it. Like what are the primary differences in architecture and implementation on Teranode?
So I mean, the biggest, easiest one is that we implemented a bunch of microservices, right? Startable microservices, and there's a 7 or 8 microservices that can run on one or more pods, as they're called in Kubernetes. So it all runs on Kubernetes. And the SV node is a monolith. It's just one application, one thing. Which I think there's a main thread. I think it's called a main thread or something like that. That also locks things up. So it's doing heavy block validation. It locks up the RPC ports and things like that. So we're splitting everything up. We kind of shattered everything into a lot of pieces. And the Teranode that we're now running it with in the test at 1 million a second, we have, I think, 40 big machines. And with something like 100 pods, so like 100 virtual machines running, doing all types of work. So that's one of the biggest differences. If you look at it from afar, if you take a step back and you look at it, then that's a Connor quote, by the way. I had to add that in there. If you take a step back, then you will see that that's the biggest thing from the outside. If you go into how transactions are processed, that's also different. So we process the transaction immediately. We kind of spend it, and then we pass the transaction ID along and use that for the rest of the processing. So there's these two differences. Architecturally, it's microservices. Conceptually, we're kind of doing transaction first instead of block first. I don't know if that's something that is fair to say. But the block assembly is really just settling these transactions into something that's fixed and putting proof of work on top of it. We're not creating like these massive blocks and revalidating all the transactions in the blocks, and at that time putting things into the UTXO store like the SV node does. There's a lot of details in there, so I mean, don't want to scare people away from. So
no, for sure. I mean, it's a complicated implementation, I'm sure, but conceptually it seems relatively straightforward. And this is what you would do with any database that you wanted to scale up, is you try to break it down into its component parts and make each of them more individually scalable. So so you said that you were surprised how quickly you were able to solve was transaction validation initially. Yes. What has been your biggest surprise? What's been the most difficult thing you've had to work on?
Actually, that's a bit of a loaded question, to be honest. No, so let's step back. The transaction validation is the first thing that we did, and some of the things that have been tweeted out by our good friends Calvin and Stefan, for instance, because nobody was allowed to say anything, but they tweeted it out anyway, which is fine. Had to do with those first steps that we made. So we have done the transaction validation. We can probably scale that into huge numbers. It's not an issue. So this is one of the first things that came out. We did 1 million a second immediately, very, very early. We have everything is sharded out except for something that we call the block assembly, where we actually take those transactions in and we create a block, like a block template that you mine against. And that's actually turned out to be one of the hardest things, because that needs to be in order. Because the way that we process everything is almost like we're streaming the transactions through the system. Yeah. And when you shard things out into multiple services, you don't have any guarantee about order anymore, because you have 50 machines doing some processing, and if one of them is a little bit more busy than the other, you have some delay there and some latency there. So the transaction comes into the system like 1-2, but the exit that system 2-1 in that sense. So we've had to we have a central point in the system in the block assembly. It's only one machine, it's a big machine, And keeping that one in sync with the network is kind of the biggest challenge. So we're running some tests now. We have a new version that we launched yesterday that ran for, I think, 20 hours really well. That's a million a second, which I think is a new record. Did really, really well. Found some issues, but the issues are mainly within that block assembly
Interesting
part, and it has to do with that order. We've actually had discussions with Craig about taking, can we just like drop that one that we don't have the topological order and transactions in the block?
Yeah.
No, we can't do that. That is part of the set in stone protocol. So unfortunately, that makes it hard, that ordering of the transactions.
Sure. Now that's I mean, it's a lot to consider. And so you mentioned Kubernetes, and I'm wondering, we have our friends who think everybody in the universe needs to run a node from home and it needs to run on a Raspberry Pi and all of those things. What does this look like at rollout? Now, you've mentioned 1 million transactions a second. I'd like to get into that too, and what that actually looks like. But what does it look like on the network today? It's for hours at a time, it's 1 or 2 transactions a second. Is really not that much going on. We've seen spikes on the network during stress tests, or crypto fights used to have tournaments and stuff where we'd see 5, 6, 7,000 transactions a second, but that would be 2-hour bursts, or that kind of thing. What does Teranode look like at that kind of scale? The sort of maybe 5,000 to 50,000 TPS. Like, what kind of hardware are we talking about? What would it take, as Gorilla Pool, for example, to run Teranode, where the your peak day on the BSV network would be something like 50,000 transactions per day, and we've never seen anything higher than that. And I'm talking like real world, maybe a year from now, if that's what adoption looks like on the network. What does our infrastructure need to look like in order to support that?
We haven't. I don't have a concrete answer for you because we haven't done those estimates. Yeah. But to give you an idea of a little bit of an idea, if I run it on my MacBook, I can get up to about 2,500 transactions a second. So that is validating, processing, creating blocks, propagating that, doing all that kind of stuff, and that's just on a little laptop with I don't know, what is it, 8 cores or 10 cores or something like that.
Yeah, it depends which one you have, but yeah.
Yeah, it depends on what you have, yes. But that would be advisable. I mean, if you want to do something like 50,000 transactions a second, I think you probably want to split that out, and you need a couple of servers. Not very big. We're always optimizing the code. So some of the servers, like the block assembly, which is a central part, is like a 192 core beast. But we're seeing lately in our testing that we don't need those cores anymore, even at 1 million a second, because we're optimizing everything down.
Nice.
So I imagine that if you have one machine with 32 or 64 cores, that would probably be plenty for estimating the next couple of years. So not to 50,000, but maybe 5 or 10,000. If you go to 50,000, probably want to split that up a little bit into different services. And the most important thing in the whole thing, the whole system, is your UTXO set. So you need a reliable database that you can scale up, because that's like the single point of truth in the whole system.
Cool. What, if any, look have you put into some of these other big scaling blockchains? It's not like we're the only blockchain that cares about scaling. We're the only Bitcoin variant that seems to, but there are somebody in the chat mentioned Internet Computer, and Solana makes some big claims, and then there's some next gen blockchains like Sui and some of these other ones that are doing I don't know what their numbers are, so I don't know if we're even in the same order of magnitude, but have you guys done any outside research to see how maybe even some of the granular things are done on those blockchains?
A little bit when we started, but we kind of took it for a green field. I think about a year ago that we started, in March or April last year.
Yeah.
Started having our first meetings talking about this, talking to Craig about this as well. And we kind of just greenfielded from our experience of scaling web applications. That's more or less where that came from. So if you have a web application, you can have a cluster database, and you have your web service, you all that kind of stuff. Think, why can't we do that with Bitcoin?
Right.
So that's where it came from. And I think we looked a little bit at these other chains, but there's thousands of them. So where do you start?
Sure.
But also the ones that we did look at, we thought, no, this is not an approach that will allow us to scale to tens of millions of transactions a second. And a lot of them are also not solving the same problem. So if you have a proof of stake blockchain, that's a very different beast than a competitive proof of work blockchain, because all the miners are competing with each other, and there's going to be forks, there's going to be blocks found at the same time, all these kind of things. So I have to be honest, we did greenfield this one.
Interesting. What about, actually, somebody just mentioned Zoken. Did you look at any of the Zoken implementation stuff? They had done some interesting work in Node, and actually we ran Zoken for a little bit at Gorilla Pool to test it out, but it's written in Haskell, and it was very hard to find anybody that had enough experience to kind of troubleshoot when we had issues. Now, Nathan, the lead developer, was great to work with, but he was in India, so time zones were a little rough, and we'd have a problem during business hours here, and it would we couldn't get to him until overnight. So for sort of practical reasons, it stopped being a good idea for us. But did you guys take any look at some of the work that was done over there?
Yes, we did. We actually did talk to them. There's some other stuff they're doing as well. They also have a Node implementation that is, I don't remember what it's called. I think it's called Zoken. It's called something else.
He had, it was Vega and Nexa, and I don't remember which one did which.
Nexa, I think it was. And we did look at that, and they weren't far enough to actually be able to demo it to us and show it to us that what we're doing. But the problem that we found was that these implementations are very complex. So you can imagine a blockchain is basically a DAG, right? Directed acyclic graph. And if you wanna really do it very, very correctly, you kind of model it like that. And that's what they were doing. So they were putting it into a graph database. And that's very nice, and that's very correct. And it's very difficult to scale that up to 1 million transactions a second. So what we kind of said, okay, a lot of the concepts that you're doing here, you're creating this graph, you're doing all this stuff, that's all fantastic, but what are you actually doing under the hood? And so the database that we've chosen now, Aerospike, which is amazingly fast, good database. They also have a graph database, and we talked to them about this, and they basically told us, well, a graph database is a layer on top of a key value store. It's like, wait a minute, we just need a key value store. So a lot of the stuff that you would put into this graph layer, we're just implementing that for the specific use case that we need in Bitcoin. And so it would probably been easier to take a graph database off the shelf and doing a lot of this stuff, and we'd had to do less work, but it's very difficult to scale that up. So we did look at that. We thought the implementation was very advanced, but also very complex. And a lot of the stuff that we're doing is trying to be as simple as possible. So can we do this validated transaction by just sending this one query to the database? No, we have to, and that's actually what we're doing. So when we get a transaction in and we're spending a UTXO, it's literally just this one update into the database. If it fails, that's wrong. If it succeeds, it's actually correct. And at 1 million a second, anything that you do, any extra query is times 1 million, right? So you need a lot more hardware, a lot more networking, and all those kind of things. So we did look at those things, but we came to the conclusion it's too complex. We don't know if into the next phase we go into scaling it further, doing other things. We might introduce some of these things, but so far for 1 million transactions a second, it's not been necessary.
Interesting. So before we get to audience questions, I'd also like to point out that there has been some public pushback from the former Teranode team about kind of the way that things transitioned and well, this is how it was, and this was done this way for a reason. And I think there's a little bit of maybe just some bad politics there. Although it looked like between you and him, there was not any ill will, but more, management decisions and stuff were irritating. But actually, the old Teranode team seemed to respect you and your input on the new ideas. But what, if any, did you glean from the old project, or maybe even any architecture documentation, which, as I understand, there wasn't much of? Like, is there any parentage from the prior Teranode system that's made it your direction, or was that also just sort of green field, as you said it?
I'm not sure if I'm allowed to tell you this. But I'm just saying. That's a Connor quote again. Just checking the box. No, we did actually have a lot of interaction with the old team. They kind of got shut down before we started, and we did look at their code, and we did look at some of the documentation, but they went into a very different direction than we were going. So we didn't take a lot from that. So we greenfielded it, and there's almost a very simple reason for that as well. Is a lot of the people that are put on the team were Go developers. So we started in Go. The old one was written in Java and C#, if I'm not mistaken. Okay. Probably mainly in Java. And a lot of the things that they were trying to solve, we were thinking maybe we just don't have to solve these things if we look at the problem in a different way. And what I've noticed over the last year, talking to various people, I haven't talked to Shatter, so I can't nothing for or against any of that. I actually don't know him either. But some of the people we talked to, we were thinking these people are stuck in a certain mindset, the way Bitcoin is implemented now. So the SV node is implemented, so the node. Yep. And they're not thinking about it fundamentally, like taking a step back and look at what are we actually trying to do with Bitcoin? No, it's like we have a mempool and we have an orphan mempool, so we have to have an orphan. No, we don't need that. Why do we need that? Is that really necessary? Is that just the implementation that was chosen at the time? So we tried to look at it much more fundamentally, and we didn't take a lot from the old project when we went into this.
Interesting. So one of the criticisms that you mentioned him, Shatters, has said that there are some things he didn't like specifically because he thought that they were maybe too cavalier, or I think he even used the word dangerous in the way that certain things are handled in the new implementation. Do you think he just doesn't have his hands around what you guys are doing, or is it just an opinion thing and engineers are going to disagree?
Maybe both.
Okay.
I mean, I don't know how he would know that. That's an interesting interesting thing to explore. Sure. But he might also be have a point. So it's something that we need to look into. And I have to admit, I mean, the what we've implemented now is a proof of concept, and some of the stuff is fairly naive. And the things that we're going to go into the next months is do very extensive testing on everything. So we're going to try to break it ourselves. And there is, I think our discussions with Craig have actually helped us in this sense, because, for instance, what is a dangerous thing in a blockchain? This is double spend. That's the problem it's trying to solve, right? And if we talk to Craig about that, he was very adamant. He just said, if somebody tries to double spend, just ban both. I think those are the words that he used. It's just that, so if somebody sends
transactions,
somebody sends a transaction, there's a second transaction spending the same input, just reject both of them, chuck them out, and don't mind them. It's like, okay, that's a different way of thinking about this problem. If somebody's messing with me, and you know what, I'm also going to freeze those things. I'm not going to allow you to spend them anymore because you're messing with the system. You're not being honest.
Right.
The word that I know appears in the white paper quite a lot.
Yeah.
And so if you look at it that way, can you take some of those dangers away, but looking at the problem in a different way?
Sure,
so
just a behavioral change.
You're trying to do,
Interesting. So, first of all, I want to point out we have almost 700 live viewers, which is a pretty good number. So you, Siggi, I don't know if it's the beard or, but everybody's very interested in this episode. So congrats. We're going to set a pretty good high water mark. So this is a pretty good audience. Brandon, if we could pull up, I see you have about a dozen questions starred. If we could start to get through them. So from YouTube user, that sounds like a German name to me. Question for Siggi. What's the roadmap after 1 million TPS? Can you make it to 2 million with existing architecture? How about 10, 1 billion? That's a good question, actually. At what point does it need to be fundamentally re-engineered again?
So we have with the current architecture, like I said, we have this one bottleneck in the block assembly, and that everything in that bottleneck has to do with the order of the transactions and how we process them in. And I think some of the tests that I've done, but this cannot be published. This is not going to be a published paper or anything like that. We still have to do that kind of stuff. I believe I could push it up to 6 million a second. So in the current architecture, with the rest of it all split out, that is like a theoretical possibility. Okay. So, but I'm not saying that is possible, because there's other things there as well. But that will be like a theoretical maximum. To go beyond that, we'd have to re-architect it. So 1 million, 2 million, we've actually done in the lab, like Calvin has said on Twitter. That is possible as well. And a lot of it is just due to cost. So we're keeping it at 1 million now. We're trying to keep everything down, because it's very expensive to run these things. Because nobody's paying us any fees. So these million transactions a second.
I know AWS isn't cheap.
AWS isn't cheap, exactly. So we could probably go a couple of million extra with the current architecture. Going above that, theoretical 6 million. We have to re-architect, especially the block assembly part. The rest is shardable. So to give you an idea of the UTXO store, which is one of the most important aspects of this, where our state is stored, it's about 13 machines that we have now, and Aerospike that we use there for it can scale up quite a bit. Just add machines so you can go further. You can do more. No, but after that, I mean, I would say after 2 or 3, we'd have to re-architect to be safe.
Interesting. But at 2 or 3 million per second, we're already talking about the fastest financial network in like the history of the world, as I understand it. I've seen some concepts on like centralized CBDC sort of things that are, claim 18 million transactions a second or something like that, but they're nothing but white papers. So I don't know that anybody's tested anything anywhere near this out in the wild, or
and this
alpha or whatever we're calling this. But
I think this is a very important point. There's a lot of these private blockchains, also proof of stake blockchains, things like that, where there's actually some coordination between the miners in that sense. We don't have that. So we have to process a lot of data from a lot of other people, and we have to expect blocks to come in at the same time. All these kind of things that if you have these other systems, you don't have to do that. Makes it a lot easier. A lot more predictable. So these unpredictabilities are what's making it complex for us, and that's a lot of the testing I've been doing over the last couple of weeks and months have to do with that unpredictability. And all of a sudden, something just going haywire, a machine going crazy, or something like that. That's
All right. Brandon, next question, please. Zap70, do you think the adoption of NAR and DAR into BSV, will it be accepted as the gold standard network, even with Teranode? I'm just hoping that things will start to develop without the drama. Well, that's a handful of things that have some drama connected to them. But actually, so let me rephrase this question a little bit, because I see there's commenters saying like there's no demand for this kind of tool. The demand for all blockchains is something like maybe 5,000 transactions a second across all blockchains, period. So why bother, pushing orders of magnitude in that direction, and also adding the kind of regulatory compliance that the supposed blockchain industry doesn't want either? What's to put it more bluntly, what the hell are any of us doing?
We're proving a point. I mean, if you think about it, I mean, Craig has been saying this for a long time. And I'm going to repeat that because I agree with him, not because he said it. That's a very important point. It's because I agree with him. Is that blockchain is basically a timestamp server. And all the value that we have, all the speculation that we have, I think is bullshit. A lot of people have made a lot of money out of that, and that's all fine, because you always have speculation when any company, any share, anything you have. But it's a timestamp.
Big money.
Yeah. And you need the Bitcoin, the Satoshis, let's use a neutral word, Satoshis, to pay for those transactions. And that's why they're there. They're to pay transaction fees to miners. And of course, there's going to be some speculation on that. But if you think about having a timestamp server that's very, very cheap, it opens up a hell of a lot of stuff that you can start doing. Because think about what is a timestamp. If you don't have a blockchain, you have to go to a notary. And I've done this in the past. And I've written some software. I want to make sure that we have it signed, and you couldn't hash it. You bring it to a notary, get a signature. They put in stupid stuff like that. It's very expensive. Now you can do that for a thousandth of a cent. You can do that with all your data. You can do it with all your digital photos that you create as an artist, or all that kind of stuff. If it's not expensive, that's what you will use it for. If it's $5 a transaction, that's insane. Create a smart contract in Ethereum and pay $5 every time I take a picture. That's just insane.
Yeah.
So no, but to open this up to different types of applications and a lot of other stuff, but also that whole idea, I just stopped. To be honest, I stopped paying attention to all the drama and things that are actually in the space, because there's so much nonsense since 2015-16, when the big block discussion happened. There's so much nonsense out there. And anybody thinking that there's a great anarchist that is going to evade the law and not going to be, seriously, if a UK judge tells you that you need to do something and the police is at your door, what are you going to tell them? You're going to tell them to go away? Are you crazy? I mean, so this is all silly. So anything has to be within the law. And I think a lot of the work that they've done on the NAR and the DAR and Connor's team is just absolutely necessary. This is what we need to move into the next phase of a utility blockchain that is actually used properly. Like it is. It's a timestamp server. Think about everything that you can do with a timestamp server. It's amazing.
Sure. Yeah. Amen. All right. Next question. We've got, actually, we're going to have to speed it up a little bit because we got a lot of questions. So is the database developer Aerospike aware that you're testing at such high throughput using their product? Have they helped or assisted in any of the implementation and data analysis? It's a good question.
Yes. Both. Yes. Yeah. We're in close contact with them, in partnership, and we're working closely with them on this, because we are also stretching some of the things that they are offering us.
They have to appreciate that, I would imagine. Maybe even AWS too. Like, have they learned?
Yeah, we're also very close contact. Yeah, we're very close contact with AWS and the people we had. We've actually had calls with like 10 people on them with a group from AWS, group from Aerospike, group from us, talking through these things, because some of the stuff that we're doing is a little bit crazy. But absolutely, yeah. No, they've been great. Both AWS and Aerospike are absolutely great in helping.
Nice. Why was AWS chosen? There's obviously other cloud providers and things. Why AWS? I
think the only answer that I can kind of give with open conscience is that we want to prove a point. If you can do 1 million transactions a second on a blockchain, on a public blockchain, proof of work blockchain, on a cloud provider, then there's no reason to say that this is not possible. Putting it on-prem or anything like that, it's even going to be faster and cheaper. But if you're doing so, to give you an idea of cost, it's going to cost a couple of $100,000 a month to run a node in AWS at 1 million transactions a second. It's a lot of money. But as a miner, you're also making a lot of money if you get all those fees.
Right.
So who cares? You're either paying AWS for that service, or you're going to have people employed to do that service. But it's I think it's kind of to prove a point that it is possible.
Yeah. Cool. Next question, please. From Nelson. In simple terms, what are the biggest challenges encountered when scaling other blockchains compared to BSV scaling with Teranode? Oh, that's an interesting question. Why is everybody else, like, what are everybody else's struggles, if you're even aware?
It's a Silicon Valley entering the picture here, and Nelson Baghetti. I think it has to do with the fact that how they're processing their transactions. So with the whole idea of having this mempool, orphan mempool, that you're validating the transaction, keeping the memory. When the block comes in, you do everything again. And what we're doing is basically processing a transaction once. If it is valid, it's valid forever. We're never going to do that again. So we kind of put that problem on its head. We change it, the way we look at it. It's almost transaction first, sort of block first, like I said earlier. But I think that's probably one of the biggest things. And
I think also just maintaining global state has its own, if every node has to stay in sync with state. I mean, that's been the biggest problem in scaling BSV applications too, is like run tokens, for example. If people want state to carry forward, and then it's just, everybody's APIs start crapping the bed as soon as blocks start getting to, 2 gigs. So state would be, in my experience, trying to maintain global state is a really difficult thing to do and scale up. So next question, please. Teranode has been out there for a while. What is your secret to getting things rolling at the pace it's going now? Actually, that's a really good question too. Teranode V1 was 3 years in the making or something like that, and didn't have a POC, but you guys have banged out a proof of concept that now is, there's a public test net that people are monitoring and stuff. What was the secret sauce? Is it just you guys are awesome, or was it just better management, better people? What is it? What does it look like on your end?
I think one of the things that they did now differently is that gives a lot of freedom. So a lot of people. So there's we kind of have a lot of almost everything we need. Not everything, almost everything we need to do this, and they give us freedom and they stayed away. So we don't have strict management on top and project management and all these kind of things. And we're running this project agile. So we're able to go very, very quickly and change things very, very quickly. So I think that is the reason we're going so fast. But I would caution that we had a working Teranode in November last year. And in a sense, like just running one Teranode, everything is validating transactions, doing all that stuff. And that's taking 4+ months to get everything working with 3 nodes. And so it's the 80-20 rule. And I think in this project, it's probably going to be the 90-10 rule, is that 90% of the work is done in 10% of the time. And now it's going to take a long time to really get everything, finalized. So we are kind of, I think it's the agile approach and the freedom that the whole management has given us to do this. I think that is probably one of the biggest ones. Cool. And collaboration with Craig. I think Craig also has given us a lot of confidence in going the directions that we actually did, because we probably wouldn't have been as brave or changing a lot of these concepts, how the transactions are processed within the node, if he wouldn't have been there to tell us, this is okay, go for it.
Yeah. Well, it's funny. He actually mentioned this on the stand when he was getting grilled by one of Copa's attorneys, and he said, "Look, you guys can act like my patents are fake or that my Bitcoin research doesn't go back to the very beginning, but I think he said it was his De Morgan patent or patents ended up being used as predicate information for bootstrapping this new version of Teranode. And so, if true, and if he can show that provenance, which I know that's." They say everything he said on the stand was a lie, but but him talking about that, it really is actually kind of a fascinating piece of information, that something that's 13, 14 years old for him, this idea for Bitcoin, could now be being implemented by your team in 2024. Is that the case?
I don't know. To be honest, I don't know how well that maps onto it, but I can imagine that is actually true. We have seen some designs for something called iDemon that is quite old.
That's what he was. That's what he mentioned. It was iDemon was the predicate thing.
Yeah, and there's definitely things that are very similar to that. But some of those things in those iDemon designs, they were made at the time, right? So the world has moved on and it's very different. So one of the things, for instance, is we're much more used to sharded replicated databases and things like that. We didn't used to have that. We have Kubernetes now that we didn't used to have that. So that design was missing some of those elements. And so that it's a little bit different. But I have always, in all my interactions with Craig, I've always felt that this is a man that is incredibly patient. I don't think a lot of people will say that, because he's living in the future. For him, this happened, 15 years ago. Yeah. What the hell? Why are we still talking about
right? Why are we so far behind?
Scaling blockchain. That's a given. That was a given to him 15 years ago. He's thinking about how to use this as a timestamp server in accounting and fraud detection, all kinds of things. Yeah. So I think he's incredibly patient compared to where he would have wanted to be in 2024.
Sure. Yeah, no, good point. I like that. I'd also like to point out we're at almost 850 live viewers now. So congrats.
I think it's on my wife. She's just on all the different devices.
I know you got a lot of brothers and stuff. So yeah, there's a lot of Óskarssons tuned in.
They're probably exactly.
So going horizontal is the latest evolution, but what about other reiterations for 1 billion TPS that Craig ultimately wants to reach? What other ideas? What do we do after horizontal scaling?
There's two things. There is specialization. So that's actually coming from Craig and coming from these old designs. So you would imagine that we have a system that has transaction validation, has block assembly, block validation, all these things, and they can be run by completely different companies. So, for instance, Gorilla Pool, is Gorilla Pool a transaction validator, or is Gorilla Pool a hasher, or is Gorilla Pool a block producer? And then you could just buy this information from it. So that's one. I think that's years away, because that changes everything a lot. But that's one of those things. Split things out massively. Another one is to shard it. But I think this is probably much more difficult. But to shard things out, not just horizontally, but like geographically. So you process something somewhere else. But that, I don't know. I think that's probably much harder there, because. Even we have a lot of discussions about overlay networks and things like you would have a UK CBDC or a US CBDC or let's take a Russian CBDC. That was very scary. We don't want anything to do with any of those people. And the miner, the Teranode, needs to process all the transactions. There's no splitting up on there. So you can't. It's very difficult to do that as a miner in the mining node, and what you're trying to do to split that out further. But I think that specialization is probably a big one.
I love that answer, because it's something I've been theorizing for like 10 years now, telling people that, hey, just like hashing became this thing that broke out of the other node operations, I'd love to see block builders and just maybe it takes 6 companies to build a block, that kind of thing. I think is really cool. So we're getting real close to the end of the show here. We got about 3.5 minutes. So Brandon, maybe let's pick the best question or two that you have. And Siggi, let's be quick with them. Has Teranode made a 51% attack, like empty block mining on the network, harder to do for dishonest miners? Interesting.
Not yet. Okay. But there we have some ideas about this. So there's a lot of things that actually Connor has been working on in the DAR and in the network rules that he's working. Is we want to automate that. We want to put that into Teranode directly, so you don't have to worry about it. You don't have to have somebody monitoring this stuff. Sure. It shouldn't be allowed. If you have a 100 block reorg, you're messing about. We're not going to accept it. We're just going to reject you. Just go away. Even if you have 51% of the hash, that's not honest. So this also goes back to a lot of the stuff that Craig talked about with honesty and the network rules. It doesn't matter how much hash you have. If you're doing something dishonest, we don't care about you. We're not going to follow you.
Yeah. Good answer. Next question, Kendra. There are some blockchains like Solana, which are known for their scaling, but why is unbounded scaling possible only on a proof of work blockchain? Or is it more difficult on a proof of work blockchain?
I actually think it's more difficult on a proof of work blockchain. I think that is more. I think the problems with Solana and the proof of stake blockchains are actually not immediately visible now, but they will be down the road when we got, we have the oligarchy basically being back, and then you have people that own a big stake. Their stake is just getting bigger, and they will actually start deciding things. The whole thing about proof of work block, I think it is harder to scale that, but the idea here is it's safer because you have these competing entities continuously competing for the block space and hashing and all that stuff, and that's why it's safer. It's not easier.
So any final thoughts? Anything you wish I asked you? Is there something you wanted the world to know, that this is your opportunity to talk to 870 people live on the CoinGeek Weekly live stream?
I think it says, "Hi, Mom."
Nice.
No, I don't know. I mean, I just maybe reiterate what I said a little bit earlier, is that when we talked to Craig, I think it was last time we talked to him in London, he basically, he had his smirk on his face, was laughing. He said, "Yeah, this is the impossible project."
Yeah.
And this is really, really hard, and we're doing absolutely our best to get this done. And we really believe in this, and we really believe in the vision. And whatever the court cases and all that stuff, I don't really care about any of that stuff. It's about a vision of a blockchain, of a timestamp server that can be used for everybody, for good. Yeah. For the world, and I think that needs to scale. I thought that in 2015, and it needs to scale to be able to do that, and that is the problem that we are absolutely committed to solve.
Yeah, I love it, man. Super. Well, frankly, proud to know you. Glad to see the progress that's being made. I think the benchmarks, the stuff you're doing, the just seeing the screenshots of your tests going on, all this stuff is really incredible. So congrats to you, and Godspeed on getting it fully shipped, which I'm I'm sure you're hard at work on, you and the rest of the team. So thanks for coming. Good to catch up. So will I see you in London in May?
Of course.
Yeah. All right. Cool.
Yes.
So Siggi, thanks again. We'll be in touch soon, and take care.
Thank you.
All right. So everybody, that was Siggi Oskarsson. Frankly, one of the coolest guys in Bitcoin. One of my favorite people to catch up with. One of the guys that I bounce off my own crazy ideas to see just how crazy I am. So really good time. So if you're watching, thank you for watching. We're at almost 900 viewers. If we can get 4 more, we'll have 900 viewers at the moment. So I appreciate it. Again, if you could like, subscribe, hit the alert bell, all the rest of that. Share this across social media. Let them know that we take questions live on the air because we fear nothing. And also go out there and be good to each other. We just hit 900. Beautiful. Love it. Thank you, people. We couldn't do this without you. And truly, I do this show for you, everybody. So let your friends know that every Tuesday at 2 p.m. Eastern Standard Time, we are live taking your questions, really taking the hard questions, talking about anything. And if you'd like to be a guest or a sponsor, please reach out. I would love to get you on the show, especially if you have a business that you are trying to bring to the blockchain or some big invention. I want this to be an entrepreneur's show or a debate show. So if you want to tell me all the reasons I'm wrong or crazy, I think those shows are pretty fun too. So please reach out. We'll get you booked up and have a good time. But before all of that, remember to be good to each other. Always be good to each other, and we will get to live in perhaps a better world. So thanks, everybody. See you next week.
BSV is more than another chaotic commodity craze. BSV blockchain can do more than just be a crypto investment. It can help you get more out of your games, share more of your art. BSV makes more things possible.